Well, good morning, everyone, and welcome to this webinar. My name is Chris Lang. I'll be presenting this content to you today. My role at Dutypoint is Product Manager, so it's my job to make sure we're selling the right products in our market that effectively serve the right people and do what they need to do. This webinar is partly based on our cold water boosting CPD, which we offer as a company. I'll talk a bit more about that later. But this particular presentation is just a short excerpt of that to begin with, but then we'll go on to a bit more of a practical demonstration of how we can use some tools that we have available to help you select cold water booster sets efficiently and effectively. Now, looking at the list of attendees, I'm generally talking to some M&E engineers, so M&E consultants and contractors, so people who generally know the industry. Because of that, I'm not going to go through in detail what booster sets are and what they're used for, because I'm assuming you already know that, and actually you're here because you're interested in finding out how to select them more effectively. So I'll talk a bit more. I'll just mention a little bit more about the CPD later. And also to say, we're looking specifically here about the selection of the correct booster set. We're not looking at the water systems in buildings as a whole necessarily. We're just looking at one part of those systems. So I'm not going to talk about things like surge relief valves, pressure reducing valves, electromagnetic water conditioners. You know, these are all important things, but today specifically we're talking about booster sets. If you do have questions on those that are related at any point, then please feel free to ask them. You can use the chat function that you should have on your screen. I can see the things you're saying as we go along, and what I'll do is I'll do my best to make comments or to answer questions as we go along. I might not be able to cover everything off, in which case I'll spend a bit of time at the end just addressing any questions that that haven't been answered as we go through. So please feel free to use that chat function, because then it becomes, you know, an interactive session, and it's really good to get some feedback from you guys as to you know, what questions are coming up as we go through this session. And just to say as well, you should be able to see my email address on the screen, chris.lang@dutypoint.com. If there's anything else you'd like to discuss afterwards, you'd like to arrange a further conversation, or just want to email a question through, please feel free to do that. I'd be delighted to hear from you. And also, if you want any more information on this topic or the topic of kind of building services in general, then our website, it has a great many resources, case studies, tools, selections, products information, to really help you. There are sort of technical guides there as well, so it's a really good resource. So please do check out our website at dutypoint.com. So just to go into the first part of our time together, just briefly run through the aims and objectives. So as I said before, we're going to look at some best practice for the selection of cold water booster sets. We're going to look at how to select the most efficient pump configuration, and we're going to explore one particular tool, actually, which has sort of tools within it to make this selection process more straightforward. So when we're selecting a booster set, we basically need to know two pieces of information to go and make that selection. So I'm going to talk about how we come up with these. So firstly, we need to determine the flow rate we need from our booster set. We then need to determine how much pressure we need from the booster set, and then we finish off with those two pieces of information will tell us will inform what sort of pump system we need. Now, there is some published guidance on this. The most recent published standard is BS-EN 806. Part 2 is the design part, and then part 3 is the pipe sizing guide. There's also BS 508, which complements this. And also BS 6700 is probably the more well-known one. It's technically been superseded by BS-EN 806, but it is actually still cited in building regulations. So it's worth bearing in mind and taking account of it. The Institute of Plumbing also offer actually a very, what we at Dutypoint think is a very, very good sort of sizing guide, and there are others as well, particularly from other countries as well, which can be useful. But these ones certainly apply to the UK. They're the main ones that we would take note of. So what these standards help you to do, and I say help you to do because we can't fully rely on standards because we need to intelligently think about what the building is doing as well. I'll talk a bit more about that later. But there's two values that are worth thinking about here. So the total flow rate of the building. So that is the total possible maximum usage if you have, say, all the showers on, all the taps on, all the baths running, all the washing machines running, all the toilets filling. Now, that is a value to take account of, but it's very rare in the life of most buildings that all the draw-off points will be running at once. So what we do is we take into account diversity and look at the maximum probable simultaneous demand. So we use some intelligent methods to think about actually what would the true maximum be. So for example, in a hotel with 80 bedrooms, you're going to have 80 showers, 80 toilets, 80 basins. Now, it's very unlikely that at any point all those showers are going to be running at once. Yes, the hotel might be fully occupied, but it's highly unlikely that all 80 guests or all 160 guests, let's say, are going to be using a shower all at once. It just won't happen realistically. So what we would do is look at the highest probable simultaneous demand, and that would be a function of the total number of units and thinking about peaks and troughs in the usage of the building. And as designers, it's important to intelligently think about that. So for example, a city centre sort of business-oriented hotel is going to have a peak demand, say between 6:30 a.m. and maybe about 8 a.m. because you've got people getting up to go and do a day of work. Whereas maybe a leisure resort is going to have a slightly different pattern, and equally a student accommodation building is going to have a different pattern. But bear in mind that things like student accommodation blocks might be used for conferences out of university term time. So then you're going to have quite a large simultaneous peak demand. So those are things to take account of, and we'll look at sort of practically how we sort of calculate these figures a little later. Now, the second thing to determine when selecting a booster set is the pressure requirement. Now, that is determined by these three components. You've got your static head, your pipework friction loss, and the discharge pressure required. The static head, you normally are looking at height here. So where is my booster set located? Normally in a plant room, typically on a basement or ground floor level. And then where is the highest draw-off point? And we use just a simple height method to calculate that. So if the highest draw-off point is, say, 20 meters high, that's equivalent to approximately 2 bar of static head or static pressure. So we add that as a component. We then look at the pipework friction loss. So what is the run of pipework? How many bends there are? What diameter is it? What material is it? And there are a bunch of formulae we can use to actually calculate what that friction loss is. There are also tools available to do this for you, as you'll be pleased to know, to save you time. So so the Hayes and Williams formula is the one we typically use. There's actually a calculator on our website. If you Google Dutypoint friction loss calculator, you will find it, and that will help you to calculate the friction loss in your system. I'll just mention as well, actually, we're releasing a second version of that fairly soon. The current version is a little bit simplistic, but we're releasing a new version soon, which will be much more comprehensive, allow you to sort of specify how many bends there are in the pipework, and give you a bit more visibility as to the mathematics behind that calculator, which is something that many of our the engineers we work with have been asking for. So that will be available fairly soon. The third component of our pressure calculation is the actual required discharge pressure. So that is how much pressure do I want coming out of my showers, taps, etc. At the other end, once we've dealt with the static head, the height difference, and once we've dealt with the actual friction loss, how much do I want to end up with at the customer side? Typically, you would take your lead from the sanitary fitting manufacturers, and they typically specify minimum pressures. But we tend to work on a rule of thumb that a good shower works at about 2.5 bar, but obviously take into account the customer's requirements as well. If it's a sort of highly luxurious sort of set of apartments or something, they might want slightly higher pressure. You also need to think about the type of sanitary fitting, so the size of the shower, the pressure requirements of the shower, and whether there are other things there like body jets and a lot of these things that you might find in more luxury dwellings. And that added together will give you a pressure which we typically measure in bar, but it can be measured in meters as well. So I hope that makes sense so far. So just to reiterate, static head, looking at the physical height difference between the water source and the highest point in the system. So obviously, typically in high-rise buildings, that's going to be quite significant. So you need to think about that carefully. But also, if the water source is higher than the outlet, you can subtract any negative height difference from that total static head calculation. And then the friction loss takes into account pipe diameters, pipework materials. And the reason you take into account the pipework material is that the friction between water and the material of the pipe can depend on how sort of porous that material is, how rough the surface is. So, for example, 40-year-old cast iron is going to be very sort of porous, very what's the word? You could bumpy, I guess. So it's going to cause more friction loss. It's going to take more energy away from the water. So you need to allow more pressure, more energy going into the water to overcome that friction. And then take into account the requirements of the installed equipment. So typically between 2 and 4 bar is what you need at the other end. 2.5 bar is normally sufficient. So once we've got our total flow rate and our total head pressure, we've got our duty point, which is what the point we plot on the pump curve to actually determine whether that particular pump we're looking at is going to be capable of doing the performance we need from it. So for example, here 12.5 litres a second is what we determined we require, and we decided we need 4.5 bar pressure, so we can plot that, as you can see on this pump curve. And you can see the duty point is below the pump curve, which means technically that pump is capable of performing that duty. Now, pump curves nowadays, they tend to look a bit more like this as well, because we have variable speed pumping technology, which means you can turn the speed of the pump down. So the top curve, 100%, shows what the pump will do if it's running at its full speed, which normally is 2,900 RPM, although it could be faster than that. And then it will show you what happens actually if the pump's running at 90% speed, 80% speed, 70% speed. But you need to bear in mind as well that the pump does have a sort of sensible minimum operating window. So the dash shaded part of the pump curve shows an area where the pump can operate, but it's not especially efficient at this point. And that's important for reasons I'll come into shortly. And the pumps typically have a best efficiency point, which can be shown in this sort of way. So you want to aim for somewhere around the best efficiency point when you're deciding whether a pump is suitable for this particular duty. Now, when we're talking about booster sets, we're typically talking about more than one pump. And there are a couple of sort of primary reasons for this. Firstly, certainly in any commercial installation, we would always recommend a booster set has at least 2 pumps, one of which is a standby pump. Now, when I say a standby pump, I mean a pump set that basically will operate at full capacity when only using one of its 2 pumps. So if one of those pumps goes down for whatever reason, the other pump is capable of carrying on as normal. It's capable of doing the maximum demand that is required by that building. The second reason we use multiple pumps, and actually the reason we might use more than 2 pumps, is that we can cover a much wider variation in demand. Because remember, typically when we're sizing a booster set, we're sizing based on the peak, what we think is the peak likely demand from all the sanitary fittings. In reality, most of the time, that pump set's going to be operating at much lower than its maximum. And typically, if we're looking at things like hotels, they often have quite a small sort of time window in which their peak demand is operating. So actually what we want to do is make sure that this pump system can operate efficiently when the demand's much lower. So for example, if your requirement is for 12 liters a second and you have two pumps, they could each do 6 liters a second. If you're using what we call a duty assist configuration, that means you've got a sort of minimum sensible flow rate that you can operate at of about 3 liters a second, which might be fine. But if we look at a 4-pump system and we've got, say, 4 pumps each that do 3 liters a second, the minimum efficient flow rate we could operate at is more like 1.5 liters a second. So if that is a place that the building is going to be operating at, 1.5 liters a second for any significant length of time, we want to think carefully about actually having a system with more than 2 pumps in it so we can efficiently serve that low demand more effectively. Now, things like pressure vessels and variable speed pumping can help with that, but pumps tend to operate most efficiently when they're at more than 80% of their full speed. So it's worth bearing in mind that you don't want a pump operating constantly at a very low speed. It's not efficient, and it's not that good for the pump either. A few other things to think about as well, things like building management system integration. What signals do you need to send back to the building management system? Is it just a fault signal? We tend to supply booster sets with a standard common fault-free contact, but you might need more than that as well. So it's worth talking about that. Low water signals is also a common request, so think about that. And we tend, as I'm sure other manufacturers do, we tend to offer a full range of inputs and outputs if they're required. So things like an external and off switch, a signal to show that one pump or all pumps or individual pumps are running, Modbus connection as well. The other important thing to note is that if you've got a pump system with multiple pumps, what you don't want is for one pump to be doing all the work all the time, because it means two things really: that pump will sort of wear and degrade much quicker than the other pumps, but also you've got risk of stagnant water being stuck in some of the other pumps, and that could lead to Legionella growth as the temperature rises. So what you do is you have the duty pump, which is the primary pump, an assist pump, which will sort of assist the duty pump when necessary, and the standby pump, which technically should only operate in like an emergency situation where one of the other pumps has gone down. But what you do is you switch around which pump is being the duty pump, which is the standby, and which is the assist pump, to make sure that they're evenly wear, there's even wear, and you don't get any stagnant water stuck in the pumps for too long. Typically, the time periods that you alternate on is anything between 1 hour and about 18 hours, just to make sure as well that you haven't got one pump that's doing all the daytime work and another pump that's doing all the nighttime work, for instance. Now, when it comes to actually sizing and selecting pumps, what we all want to do as specifying engineers is to find the most efficient pump for the system that we're designing. And typically that manufacturers published something like this. It is a curve sort of chart that has lots of different pumps in it, all from the same range of pumps, all with the same sort of flow range, but with different number of impellers so that they can do different levels of pressure. Now, when selecting a pump, you might just need to look at one of these, but really what you should do is look at all the different options available to you to find the most efficient pump. It might actually be that a flow size higher than this set of pumps is ideal, or it might be one that is slightly lower. And then you've got different manufacturers. You've got whether to do a sort of 50 hertz motor pump, which will run at 2,900 RPM, or a 60 hertz motor based pump, which is going to run more like 3,600 RPM, or you can go higher than that. And at that point, you've got quite a lot of options to look at. So suddenly one set of pumps becomes a heck of a lot of pumps, basically. And realistically, most engineers won't have time to look through 20 different charts of this sort, or there's potentially sort of 100 different charts that you could look at to try and find the most efficient pump for doing your duty. Now, realistically, we don't think that most engineers are going to have time to look through this many charts to select the right pump. So what we've done as a company is created a tool which you can use to actually essentially do the process I've described, but much quicker. So I'm just going to switch over to that in just a second. So this is our product selector. Now, just to give you a bit of background as to what this does, I was sort of involved right in the conception of this tool. It's available on our website. It's kind of an early version of it, but it is available for you to use. We're still making improvements on it, but it is available to use. And what we did is we sought to actually replicate the way an experienced specifier would select the right booster set for a particular application if they had basically unlimited time. So if they could spend all the hours looking through every single pump curve that could possibly be used, and measuring the efficiency, measuring the turn down, measuring the minimum flow possible, looking at other factors as well, the power consumption, the minimum viable flow rate, the tolerance between the point I've selected and the maximum flow rate of the pump. If you're taking all those factors into account, and looking at every single possible option available to the specifier, if a human could do that, it would take them a while. But what we've done is try to develop a system which essentially does that, but much faster. So rather than taking several hours, it just takes a matter of seconds. So I'm going to demonstrate this to you now. So this is the sort of the main window. We've got just three main options here. So flow rate, which we talked about earlier. The head pressure. So as we said, the static head plus the friction losses in the system plus the discharge pressure required. And then with pump configuration. So single pump, which can be useful sometimes, but also duty standby for a twin pump system where one pump can do the entire peak demand of the building. Duty assist would be where the two pumps working in tandem would be able to deliver the full flow rate, and so on and so forth. So duty assist standby, two pumps together are able to do the entire demand, plus one standby pump. Duty assist is where you have three pumps that can all share the demand between them, and when all three are working together, they can do the peak demand. Right up to 8 pumps, all sharing the duty, or say 7 pumps plus a standby pump. So typically we're looking at things like duty standby for one pump doing the full work and a second pump as a standby. So I'm going to do an example just to show you how this works. So now there are other manufacturers that have a sort of calculator like this. But what we've done in addition is actually given you this peak flow rate calculator, which is a tool that you can use to actually determine what your peak flow rate is in a certain project. So I'm going to give you an example of, a primary school where we've got a certain set of criteria. So wash basins to start with, there are 20, 5 kitchen sinks, 20 toilets, probably no baths in a primary school. Let's say 3 standard showers, 10 urinals there would be 10, roughly. Let's say 2 commercial washing machines, maybe a couple of outside bib taps. So just an example. That's not based on any specific project, but if we imagine a primary school, it would probably be something like this. You've also got the option to say commercial usage, domestic usage, or low usage, half user one. So commercial usage is typically what we're looking at. Click a button there, and that is loaded into the calculator. And then I'm just going to assume it's a fairly standard, maybe single or double story building. So 3 bar pressure would be sufficient. And then I've selected my duty standby because, particularly for a school, actually, if you'd want to have that backup there in case of a first pump failing, you'd want to have a standby pump typically, just for that backup. So hit search. And what the calculator does at this point, it looks through every single option available in the product range, looks at every efficiency point, every power consumption curve, every minimum flow rate, and then brings you back some options. So here there are 3 products from our range. There are different kilowatt values here and efficiency ratings. Now it should have actually shown me a pump curve here. So I'm just going to refresh it here. There we go. For some reason it didn't show up before. And there's the pump curve. So you've got showing your 3 different options here. So what the system has done is gone through every single pump that we offer in our range and worked out basically the most efficient options. Now it's determined there are sort of 3 decent options here, but actually typically it would give you 1 or give you 2 options, as it would be typical. And here the blue point you can see is our operating point that we've selected, so 1.4 litres a second at 3 bar pressure, and then 3 pump curves showing 3 different pumps that can that could perform this could do this duty reasonably efficiently. We've got the different efficiency ratings here as well. Now, one point I would make about efficiency is that quite a lot of manufacturers have been talking a lot about efficiency, which is great, but this percentage can be slightly misleading when you're looking at pumps. What this percentage is, it is the percentage of what's called a pump's P2 value as a function of its P1 value. Now, the P2 value tells you the amount of energy which exists at the pump's impeller when it's rotating. So the amount of energy that gets actually imparted to the water that is being pumped. The P1 value is how much energy you actually need to put into the pump in order for it to get that percentage out of into the impeller and actually into the water. So for this pump here, 68.3% efficiency means that when you put in 0.624 kilowatts, you get 68.3% of that 0.64 kilowatts actually at the impeller. That's a fairly decent amount. It can be higher, it can be lower. But if we look at these 3 efficiency ratings, they're all pretty similar. Whereas in actual fact, the energy that you're using is quite different. So this pump, this pump here, the VR20505-LHM, to do this flow rate that we've asked for would take 0.64 kilowatts per pump. Whereas this pump here, even though it's only looking like it's very slightly it's looking slightly more efficient, actually it's using more energy to do this flow rate. So it's worth taking into account this. And yes, variable speed pumping will sort of alleviate that, but still, you can't just rely on the efficiency measure to determine which is the most efficient. Because actually this middle option here is, it's a smaller motor than this third one, and therefore it would actually use less energy to do this particular flow rate that we've asked for. So assuming we don't need a massive amount of tolerance, I would select this one because it actually has the lowest energy consumption at the operating point that I've requested. I hope that makes sense. Now, also in our calculator here, we've got a combined tank and booster selector, which is used for selecting our scuba tank product range, which combines a booster set and a brake tank all in one unit. I'm going to use a slightly different example here, and we're going to think a bit about brake tank capacity here. Now, an example where standards like BSEN 806 don't necessarily kind of work particularly well are things like sports clubs. Now, if you imagine something like a rugby club, and there are excuse me, who have matches. The matches happen, and the team come back into the changing rooms, and typically they all get into the shower at once and all use the showers at roughly the same time. So you've got this long period of very small use, followed by a massive, followed by a particular period of very strong demand, possibly using all the showers they have. So in a case like that, when we use our flow rate calculator, say we've got 20 showers in this rugby club, I'm going to change this to size them based on all those showers being used at once, because of that usage pattern, that potential usage pattern. As something like a rugby club, it's highly likely that all those 20 showers could be used all at once. So what we don't want to do is size on a diversity curve, because there's not going to be much diversity at that particular period in time. So the pump set that we're sizing has to be capable of coping with all those showers on all at once. We found that there was one of my colleagues actually had an example of a veterinary college where this was true as well. So all the students went out into the fields and did lots of lambing at a particular time in the morning, all came back and had showers at once, and they were finding that the system couldn't actually cope with it. So that's why we have to think intelligently about the usage pattern of the building we're designing. So in this example, I'm going to use that flow rate there of 3 litres a second, because I've got all these 20 showers all used at once. And let's assume it's a single story building, so 2.5 bar. We'll go for a single pump configuration. Tank capacity, we've also got a calculator for this, which is based again on the BSEN 806 standards. You kind of have to be, again, slightly intelligent on how you use this. So the standards actually say that in a typical hostel, which you would also use for sizing any sort of domestic dwelling, you'd be looking at about 90 litres per bed space. So if I say we've got 22 bed spaces, for example, it's going to give me a tank requirement of 180 litres. You could also look at something like a time storage formula. So a rule of thumb we often use is to size a brake tank for about 15 minutes of continuous usage. So 3 litres a second is 180 litres a minute, which would be 2,700 litres, for instance. But typically, this is going to be governed by the space available, so the space that the architect has allowed. So I'm going to go for a slightly lower, say that 1,500 litres. My search based on that. And here, very similar results here. So 2 products with tolerance ratings, kilowatt per pump, so actual energy consumed into the pump. And we're not showing an efficiency value here, but you can clearly see that this first option here is using far less energy at this operating point. And that's this red pump on the curve here. So again, what this system has done is gone through every single option, calculated the efficiency, calculated the energy, and it's come up with basically what it determines is the most efficient solution. And it uses a sort of a scoring algorithm to do that. It gives a certain pump a number of points for being very efficient. It gives it points for the operating point not being in this kind of the dashed area of the pump, which is where it doesn't operate very efficiently. It gives it more points for it being at the right-hand side of the curve, because that is where pumps typically can operate at their best, is when they're at their sort of full operating speed. So hopefully you can see that what we've done is created basically a computer algorithm that mimics the way an experienced specifier would select this pump if that person basically had unlimited time. So I hope that makes sense. Now, a few other points to note would be things like noise rating. So where are you going to site this booster set? Particularly in luxury dwellings, combined tank and booster systems are good because the pump is typically within the unit. So in our units, the scuba tank, the pump is inside the brake tank, so it cuts down noise as well. If we're looking at luxury dwellings, we would typically base them on half the showers being used at once. So say a 10-bedroom, 10-bathroom house, 10 showers, they'd probably be high-flow showers as well. So we actually use this one down here. So I'm going to set that to 0, and actually high flow showers, we'll say half used at once, and there are 10 showers. 10 showers. And that will give us a flow rate to use in our calculations there. So 2.5 litres a second in this case. And again, we can use the hostel setting from BSEN 806, and that will give us a tank capacity, which then we can use to search for the best solution. Hopefully that gives you a nice flavour of product selector. You can find it on our website or just Google Dutypoint Product Selector. This is an early version of it. We're going to add some features shortly. Certainly in the future, we want to add the ability to sort of save selections and recall projects that you've kind of done in the past. We're going to have easy access to BIM files for these products. So currently you can look at a PDF or a DWG drawing and download that really quickly. We're going to add BIM into that as well. We're going to have other configuration options like power supply, BMS requirements, that sort of thing. And we'll give you a written specification as well that you can just sort of use in your specification that you're writing. Pricing certainly for budget purposes would be probably a good addition. And we're going to add a little calculator to help you, do the head pressure in a meaningful way. And also, we'd really appreciate hearing your feedback on any other features that you'd like to see in a product selector like this. So I hope that's sort of giving you a good guide, and hopefully you'll go and try this on your next selection. Now, I did mention earlier that we offer a CPD that goes into more detail on this. It's a CIBSE accredited CPD on cold water boosting and design, sizing, and selection. Part of the content that I've been through today has been sort of taken from that CPD. But if you would like to get some CPD points and also learn even more about selecting the right booster sets, best thing to do is go to our website, dutypoint.com, then /CPD, and there's a page there where you can fill in a form to actually request someone to come and arrange a session at your own premises. Or if you'd like to, come and see ours and maybe do a factory tour at the same time, that's available to you as well. But yeah, that kind of covers what I was going to go through today. It's been a bit of a whistle-stop tour of sort of booster set selection. I hope you can see there are lots of places where there are standards available to help you, like BSEN 806, but actually as a specifier, you need to kind of go beyond the standards a bit. You need to think intelligently about what the building is doing and what the pump set is doing within that building, how it's going to be serving it best. So you can't just sort of hide behind the standards, because if BSEN 806 says this, it doesn't mean you can just specify exactly what it says. You need to think intelligently about the system. So I hope that all makes sense to you, and I hope you can see that finding the most efficient pump system for a particular project is a much less laborious task if you use our product selector. So I hope you make use of it. Please do fire any questions over to me. You've got my email address down there, chris.lang@dutypoint.com. And I'll hang around for a few minutes actually in the chat area. If you do have any questions at all, please do just fire them away, and I'll share them if it's appropriate. But otherwise, thank you very much for joining us this morning. Any questions, please get in touch with our team. We're more than happy to help, and we'll let you know about any future webinars as well. But thank you very much for joining us this morning.